Before we move on to actually code something, I want to go over one more thing. I have a question. Why do we have both load graphics content, which initializes to graphics card memory, and initialize method, which initializes variables to the RAM on the motherboard? Why can't we just mix them up and do everything in initialize? Well, let me do the long explanation so it sticks. Managed DirectX is the old name for XNA before the Xbox 360 came out. The word managed simply means that C# will take care of the memory garbage collection, so we don't need to actually have so many destructors in our code. And managed DirectX is a version of DirectX, which is what professional game developers use because they don't want anything managed for them. They want to manage everything by themselves. DirectX simply means direct access, meaning that you write directly to the RAM on the graphics card, for example. You don't tell Windows to write to graphics memory for you. You do that yourself. However, direct access does not mean that you have exclusive access to, for example, the graphics card. Uh, I can show you how this works, but I'll explain device first. Device is simply a computer term or programming term for hardware or a class dealing with the hardware. And the problem is that since you don't have exclusive access, that means that some other program might gain control of the hardware, such as, for example, if a screensaver kicks in, and that screensaver might overwrite things in graphics memory because it also has direct access. So it can do anything it wants. It's not stopped by Windows. This is called a device reset. It simply means that you lost control and then you got it back. And since we don't know if anything has overwritten memory, we need to check if that's the case. And if that is the case, then we need to call load graphics content again to reload everything. That's why you separate things into initialize, which is only called when you're starting up, because you get to keep all the RAM on the motherboard for yourself. No other program can steal that from you. But since you have direct access and other programs have direct access to the graphics card, you might lose that. So you need to separate that out into its own method. Now that you know this, I'll go over quickly how we can load a graphics and display a piece of graphics in XNA. XNA comes with a class called Content Manager. We'll instantiate that into an object we call content. The load graphics and unload graphics are the methods that we will use to load and unload. And for this we need a few more classes. We need a texture 2D class, which is another XNA class for handling an image. We will instantiate this one into myTexture, the myTexture object. We also need a sprite batch class, which XNA provides for actually drawing the images. This one passes everything to the graphics card memory. This one passes it from the graphics card memory through the CPU and out to the GPU, not CPU, to the actual monitor. And we will also use an XNA structure, a vector2 structure. A structure is, I won't go into detail what it is now, but it's similar to a class. It's just a bit more simplistic than a class. And we will instantiate that vector2 into a variable we call sprite position. So we have we have four objects that we will use. So we'll have sprite position, sprite batch, my texture, and content. And then since earlier we also have graphics, if you remember. Inside this content, there are a few methods that we will use. The load method loads everything, and the unload method unloads everything. So these two methods we will call inside these two methods. And the sprite batch has three methods that we will also use. The begin method sets everything up for the hardware, so the hardware knows how we want to draw the images, if we want them to be transparent or glowing or whatever. And the draw method is a bit oddly named, but that is to match the name of the main method draw, because we will place these three in the draw method. It actually doesn't draw anything to the screen, it just collects information. It collects all the textures and everything else to draw to the screen. And then when you call end, then that is when it actually tells the hardware to draw. Okay, let's look at some real code in Visual C# and actually draw an image to the screen.